Hello, Algebra 2. Today we're going to start Chapter 3, and Chapter 3 is called Systems of Linear Equations and Inequalities. So today specifically we're going to talk about 3.1, which is just solving linear systems by graphing. So we're going to talk about 3 ways of solving. This is our first one, totally devoted to graphing. So let's start by recalling, what does it mean to be a system? So here the definition is going to be a system of 2 linear equations, and it's just 2 equations at the same time. And we're going to be dealing with just linear equations right now, but as we progress throughout the year, we are going to be dealing with systems of nonlinear equations. So they don't have to be linear, and it doesn't just have to be 2. So essentially, it's a group of 2 or more equations considered at the same time. Right now, though, we're starting with 2 linear equations, and we want to find the solution to this system, and the solution is going to be the ordered pair that satisfies both equations. So right now we're going to do this graphically. That ordered pair comes from their intersection. So it's that ordered pair that would be on both lines. So to check to see if anything is a solution, we just always plug it in. Here, though, we have to be extra careful that it does work in both. So I'm going to check the point 1, 4. So checking it in the top equation, and I'll just write down what the equation is. So if I put in x is 1 and y is 4, so I get 1 minus 12, and does that equal negative 5? Or in other words, does negative 11 equal negative 5? No, it doesn't. So because it didn't work in the first one, there's no reason to check it in the second one. Okay? But if it worked in the first one, then we would need to check it in the second one and say whether it worked in that one or not. So no, the first one's not. I'm going to leave the second one for you to check as a quiz question. So go ahead and make sure that you have that information because you're going to need it to answer your quiz question. So now on to solving the system. And like I said, today we're going to solve by graphing. So what you want to do is you want to put both lines in the slope-intercept form and just graph them. We do want to do slope-intercept form and not standard form with the intercepts because I think you're a little more accurate on points. And you want to be really careful that you actually get their exact intersection. Now, they might not have an intersection. Let me draw in 3 coordinate planes here. So there's actually 3 types of solutions you can have, or 3 numbers of solutions. So the first one is where they do actually cross once. So you could graph 2 lines and they're going to cross someplace, and where they intersect is going to be your solution. And I want you to think, could 2 straight lines ever cross twice? Or could 2 straight lines ever cross 3 times? So think about that and think about, if they do intersect, does it just have to be once? So the second way, though, that they could be is that they could be parallel, in which case there would be no solution. Because our solution is an ordered pair that works in both, and if they don't cross, there's no ordered pairs that work in both. And our last one is that the lines are actually the same line. So if that's one line, then let's see here, then that would be the other line. They're the exact same line. They're going to cross everywhere. So they are said to have infinitely many solutions because they share every single point. Alright, so let's look at an example. So it will tell you solve by graphing, and in that case we're going to graph. So if I take the first one here, and I first of all want to get it into slope-intercept form, so I'm going to move the 2x to the other side. So negative 2y, don't drop that negative in front of the 2y. Negative 2x minus 8 divided by negative 2. Y equals x plus 4. Okay, and I'm going to graph him in blue here. So I'm going to start at 4. And go up 1 over 1. Now, because I have at the moment no idea where they're going to cross, typically I will draw in extra points, and I'm not going to draw my line in yet, because sometimes when you draw in your line, it doesn't go exactly where it should go. So I'm going to leave that just like that at the moment. And I'm going to look at the other one. 2x plus 2y equals 4. Do the same thing here, subtract 2x. So we get 2y equals negative 2x plus 4, divide by 2. Y equals negative x plus 2. Okay, so I start at 2 and go down over 1. But see, if I go this way, they're not going to cross going that way, so I need to go back the other way, and look at that. I found where they cross. Now, you need to draw in your line. So just because I found where they cross, okay, if it says solve by graphing, I want the lines completely graphed, so we're going to draw in the graph. But then our solution is where they crossed. So where did they cross? Okay, they crossed at negative 1, 3. That is our solution. So everything else here, all of this is all work. Even the graph is work. Everything here is work, and you need to show your work. This is your solution. You need to also make sure you show your solution. Okay, that's it for today. Let me know if you have questions, and I will see you in class. Have a great day.